In this lesson, you're going to see if the relationship in the table shows a direct variation. So what is direct variation? When the ratio of two variable quantities is constant, their relationship is called direct variation, meaning that it is proportional. The constant ratio is called the constant of variation. In a direct variation equation, the constant rate of change, or the slope, is assigned a special variable, k. So the direct variation, in words, a direct variation is a relationship in which the ratio of y to x is constant k. We say y varies directly with k. So it can be written as k is equal to y all over x, or y is equal to kx, where x is not equal to 0. An example of it, like in this equation that has been graphed on the line, y is equal to 3x. The graph of a direct variation always passes through the origin. Okay, so in example 1, direct variation in tables. These tables must show proportionality. The table below represents the number of quarts for every gallon. So let's take a look. Remember, it's the ratio of y all over x is equal to k, or y is equal to kx. It can be written in a couple of different ways. Well, let's take a look at this ratio of y all over x. When I have the y all over x, I've got 4 all over 1. And these are proportional because in all of these cases, 8 all over 2 is reduced back down to 4 all over 1. If I do the same thing with 12 all over 3, I still have 4 all over 1. 16 all over 4 is equal to 4 all over 1. So my constant rate of change is 4. X is being multiplied by 4 in each one of these instances. So does this relationship show direct variation? So yes, it does. Write an equation that relates to the number of quarts for every gallon, where our y here is equal to our constant of variation is 4, and it's going to be times x. So in each of these cases, 1 times 4 is equal to 4, 2 times 4 is equal to 8, 3 times 4 is equal to 12, and 4 times 4 is equal to 16. Alright, so tell if each table models direct variation, and if so, find the constant of variation and write an equation. That constant of variation, remember, that is the constant of variation, that is a k. Remember the equation for direct that shows direct variation is y all over x is equal to k, and we've got y is equal to kx. Alright, so let's take a look here and let's find the ratio. And first of all, one of the things that we had mentioned in the first slide was that direct variation will go through the origin, which is 0, 0. So right away, when something goes through 0, 0, it is going to be modeling direct variation. So, but let's take a look at the ratios. Let's do y all over x. So I'm going to take my 2 all over 1. Well, that's simplified down to 2. Let's take the 4 all over 2 is equal to 2, and 6 all over 3, that's equal to 2. So our equation that we have here is y is equal to, because 2 is our constant of variation, y is equal to 2x. Because if you go and you plug in, when x is 0, 2 times 0 is 0. When you plug in 1, 2 times 1 is 2, and so forth. Alright, let's take a look at another one then. Our next one, we've got 10 and 2, and that simplifies down to 5. When we've got 14 all over 4, well, that does not simplify down to 5. And so in this case, this does not represent, no, it is not direct variation. And then in that first one, we suppose we should have done that. Yes, this one is. All right, number 3. Well, here we've got another one that goes through the origin. So we know that that one's going to be proportional, but let's go ahead and try out the rest of them. I'm going to take 1,000 all over 2 is equal to 500. 2,000 all over 4 is equal to 500. And 3,000 all over 6 is equal to 500. So our constant of variation, or our k, this is the k that we're talking about, because it's y all over x, this is y, this is x, and that's equal to k, is equal to 500. So our constant of variation is 500. So we can say that y is equal to 500x. Oops, I can't write that there. Okay. All right. All right, so let's go ahead and take a look at our last three graphs. I'll write our equation up top here that shows direct variation. Y all over x is equal to k, and y is equal to kx. All right, so in our first example then, I've got y all over x, which is 1 all over 25. I'll go to 2 all over 50. Well, that's equal to 1 all over 25. 3 all over 75 is equal to 1 all over 25. So our constant of variation is 1 all over 25. So I've got y is equal to 1 all over 25 k. Oops, I'm sorry, x. All right. Now on our next one we've got 36 all over 2. Remember, it's the y all over the x, and that's going to be equal to 18. Well, 52 all over 4 is equal to 13. So right there we know this is not a direct variation. Where in our first one was yes. Those are proportional, or they showed direct variation. All right, in our last example then, we've got 12.5 all over 5, and simplified that's 2.5. 25 all over 10, simplified is 2.5, and if I do it to the others, it's the same thing. So our constant of variation is 2.5. So I've got y is equal to 2.5x is my equation, and yes, this models direct variation. So in this lesson, we took a look at tables and if they represent direct variation or proportionality.